We're continuing section 14.6, units in the chain rule. So let's see z be z of x and y, function of x and y, x function of t, y function of t, so that the chain rule says derivative of z with respect to t is equal to partial of z with respect to x times derivative of x with respect to t plus partial of z with respect to y times derivative of y with respect to z. So these units kind of make sense. It's like you're just imagine t is time in hours, and this is an example. Y is the temperature in Celsius, in degrees Celsius, and x is length in meters, and z number of bananas. So the units of chain rule, if you look at it, the partial with respect to z with respect to x is bananas per meter, and then dx with dt is meters per hour, and then again meters per degree centigrade and degree centigrade per hour. And you're kind of adding them up, but the units are going to end up to be bananas per hour for both terms. And so basically you find that if you're walking and walking around, and depending on the x meters that you traveled, the number of banana changed, and depend on the degrees that are changing, the number of banana change, and you add them all together as time goes by, basically. And so that's the point of the chain rule. It totals up the change. Or why the chain rule works. This is kind of optional. So basically, there is a similar proof to the chain rule of one variable and single variable calculus. And so when you're talking about the derivative of z with respect to t, you're talking about the difference between function f of x plus delta t and y of t plus delta t minus f of x of t and y of t over delta t. And as delta t, this limit as delta t goes to 0. So yeah, delta x and delta y are going to go to 0 as delta t goes to 0, because x and y are differentiable and continuous. So let's start with rewriting this equation up here, this limit. And so the same trick applies that we used to do in Calculus 1. You can add and subtract this term f of x and y plus delta y, and f of x and y plus delta y, added and subtracted. Notice that there's a delta x and delta x multiplied when this term was subtracted and added. You multiplied by delta x and delta x, and then you basically separate these into 2, and there are 2 limits and 2 limits over here. There is some mean value theorem stuff going on here, because you don't have quite delta t going to 0 and delta t going to 0, implying delta x goes to 0. But yeah, and for the first time we're talking about that this is not exactly the proof of it. It just, you have to use the mean value theorem when things like that happens. But then it ends up to be this limit is going to be f sub x as x and y, and that one ends up to be x prime of t, and here also. So you get the chain rule out of that. Okay, now time to do the chain rule tree for a function of 3 variables. So let w be f of x and y and z, and x be a function of t, y function of t, z function of t. Again, the chain rule formula for derivative of z respect to t can be presented by a tree. So where do you start? You start with w on top, and then what are the w is a function of x and y and z. So you start with w, you go down x and y and z, and then all three of these are functions of, and as you go, each little branch that you create, you write it as a derivative form. Here is w as function, a multivariable function, so derivative of w respect to x has to be partial, and w again with y, it would be a partial of y, w with respect to y, and with z. And then you go down to what x and y and z are functions of, and then each branch 1 is just this value multiplied by that, and branch 2 again each piece multiplied together, and branch 3 multiplied together, and then you add them all up and it becomes the chain rule for a function of 3 variables. So another case of chain rule. Now, let's say for any composite function involving multiple variables, we can keep track of the chain rule using the tree. Now, let's say f is a function of x and y, x is a function of s and t, y is a function of s and t. What is going to happen? By the way, the formula is going to be the partial of z with respect to s is equal to partial of z with respect to x times partial of x with respect to s, and partial of plus partial of z with respect to y times partial of y with respect to s. And then the other one, partial of z with respect to t, is going to be partial of z with respect to x times partial of x with respect to t. And again, partial of z plus partial of z with respect to y times partial of y with respect to t. So how does this happen? You start from z, and then you go down to x and y this time goes to down to s and t. Now, each branch, the branch that go from z to s is going to show up in the first one. So there are 2 branches that go from so I'm looking at travel from z to s, one route and another route right here, and that gives me this one is partial of z with respect to x. Z and x are connected, and x has 2 variables. Again, you have a partial of x with respect to s. Over here is partial of z with respect to y, and then partial of y with respect to s. This times that plus that times this, and you get the partial of z with respect to s. And so you see all of them are partials, because then going from the z to very bottom they're s and t, and going from z to x and y all partial, from x and y to s and t are all partial. And so the second one is similarly, highlight goes the other way around. Basically this time you get the highlight going from here, then there, and over here, and you compute them and you get 2 terms for the 2 branches of the chain rule. So let's do an example. Find the partial of z with respect to s and partial of z with respect to t if z is x squared, y plus 2xy squared, and x is st squared, and y is s2t. So how do we go? Partial, start with z, going down x and y, then going down s and t. And so the partial of z with respect to s is going to be these two branches, and so it's partial of z with respect to x times partial of x with respect to s plus partial of z with respect to y, partial of y with respect to s. Now, what is partial of x z with respect to x? Partial of z with respect to x is 2xy plus 2y to the fourth. What is partial of x with respect to s? That's t squared. What is partial of z with respect to y? That is 2 over here. Partial of z with respect to y is x squared plus 8xy to the third. Partial of y with respect to s is just 2s. Okay, so this is not bad. We figured out the derivative. Here's the problem, though. I have x and t sitting there all together. What should I do? I should replace x by st squared. So 2 times st times y, what, s2t plus 2 times s2t to power 4 times t squared plus st squared to power 2 for x, 8 times st squared times s squared t to power 3 times 2st. And so that becomes the partial derivative with respect to s. And if you clean it up, I click here question 14.6a. So a table is given, and f of u and v is equal to g of x of u and v and y of u and v. And then they're asking to compute partial of f with respect to u at 3 and 4. So take a break and come back. Let's start with basically the chain rule tree. So if you start from z, that would be the z, and you go to x and y, u and v, u and v. So the partial respect of z with respect to x, that's the one that involves g. This is g of x. This one is g of y. This one is x sub u. This is x sub v. Y sub u, y sub v. And so which two branch do I want? Here's one. Here's the other. Let's put them together. So f sub u of u and v is going to be g sub x times x sub u plus g sub y times y sub u. Here it takes x and y. Here it takes u and v. Here it takes x and y. Here it takes u and v. Okay, so what does it mean one takes x and y, one takes u and v? Hold on. If u and v is 3 and 4, then x and y are going to be 1 and 5. So let's start over. F sub u of 3 and 4, see f takes u and v, is equal to g sub x of 1 and 5 times x sub u of 3 and 4 plus g sub y of 1 and 5 times x sub u of 3 and 4, right? So what is g sub x at 1 and 5? That is g sub x is right there, g sub y is right there. I can replace this with 2, replace the other one with -1, replace x sub u of 3 and y, 3 and 4 by -1 again, and x sub u of 3 and 4, x sub, sorry, this one is y sub u. And y sub u of 3 and 4 is going to be replaced by y sub u by 6. And multiplying together, -2 minus 6 gives me -8. And B is the answer. Now, next question. Everything is the same, except this time it's asking for f sub v rather than f sub u. So basically, the two branches that we didn't use are going to be used, and that gives me f sub v of 3 and 4 is equal to g sub x of 1 and 5 times x sub v of 3 and 4 plus g sub y of 1 and 5 times y sub v of 3 and 4. And then find the values. G sub x at 1 and 5, we already know from the above it's going to be 2. The other one we know also, -1. X sub v is -3, and y sub v is 4. So when you calculate, you end up with -6 minus 4 equal to -10. So I got here 14.6b is A.